Okay, let's unpack this. Today, we're embarking on a deep dive into artificial intelligence, AI. It's everywhere, reshaping pretty much everything.
Absolutely. Hard to avoid it.
Exactly. And beyond the headlines, we're getting to a really critical question. Can we actually trust these machines?
That's the core of it, isn't it? Trust.
Yeah. So our mission today is to sort of figure out what makes AI trustworthy, or maybe more importantly, what makes it unreliable.
Right. We need to look under the hood a bit.
We do. We'll start with the basics, how AI even learns, then we'll get into the trickier stuff. Bias, fairness.
Transparency, or the lack of it sometimes.
Right, the whole black box idea. And of course the risks, the societal implications of just blindly trusting algorithms.
We've pulled together insights from, some key figures in machine learning, AI architects, trying to get a balanced view.
We have. We want to give you a clear, nuanced picture of what's really at stake here. So let's get started. 1. The foundation, how machines learn and where trust begins. Okay, first things first. Before we can even talk about trusting AI, we need to understand fundamentally how these systems are built. So what is machine learning, really? How does that connect to trust?
Well, machine learning, it's the part of AI where the algorithms basically program themselves.
Program themselves? How?
By learning from data. Lots and lots of data. Think about identifying spam emails. Right? You don't write code saying, if it has this word, it's spam.
Okay.
Instead, you feed the system thousands, maybe millions of emails already marked spam, not spam. That's supervised learning.
Supervised. Because humans label it first.
Exactly. The machine then looks for patterns, correlations in that labeled data. What features tend to show up in spam?
Got it.
It builds its own internal model, like a set of rules, or more accurately, mathematical functions to tell the difference. Then it can predict if new unseen emails are spam or not.
So it's not really understanding spam like we do. It's more about recognizing statistical patterns that usually mean spam, like finding the best mathematical line to divide the data.
Precisely. That's a great way to put it.
Yeah.
And this model, it's trying to apply that learned boundary to new data. Systems like support vector machines, SVMs, they do exactly this. They create these decision boundaries, sometimes really complex, nonlinear boundaries to separate data points as accurately as possible. It's essentially solving a big optimization problem, finding the best internal settings or weights to make the fewest mistakes.
It's amazing how fast they learn. You look at AlphaGo beating Go champions.
Right, through reinforcement learning, playing itself millions of times.
Or systems describing photos now.
Prem captioning, yeah. Phenomenal stuff.
But, and this seems key, their success often depends heavily on having tons of that labeled training data.
Yes, and that very dependency, that need for huge data sets, is, ironically, where our first big trust issue comes in. Because if the data itself is flawed or biased, well, the whole system built on it inherits those flaws. Doesn't matter how clever the algorithm is.
Which leads us right into bias, too. The blurry lines. Bias and fairness in AI. Okay, bias in AI. When we talk about this, it's not always like deliberate prejudice coded in, right? Often it's just reflecting the biases already in the data.
That's a really critical point. Often, yes. If the data you train an AI on is biased, the AI will be biased. And that can have serious, even dangerous consequences in the real world.
Can you give an example?
Sure. Think about facial recognition.
No.
Fei Li has pointed this out. If these systems are trained mostly on pictures of, say, white men,
Okay.
they often perform much worse for women or people with darker skin tones. They might fail to recognize them or misclassify them. The system isn't necessarily trying to be biased. It's just learned from skewed data. It reflects the imbalance in its education.
So it's like the algorithm is fine, but the diet of information it consumes is bad. Garbage in, garbage out, basically.
Pretty much.
Yeah.
And sometimes it learns things that are completely irrelevant, statistically speaking. There was this example, a system trained to spot animals.
Yeah.
But in the training photos, maybe all the animals happen to have blurry backgrounds, just a coincidence in the data set.
Right.
So the system might learn that blurry background is part of what makes something an animal. Show it an animal against a sharp background, and it gets confused. It overfitted to an irrelevant detail.
Wow. So it learned the wrong pattern.
Exactly. It learned what it saw in the data, which wasn't necessarily the core concept a human would focus on. And that gap between the AI's logic and our logic is where trust really starts to fray.
That makes sense. It's learning differently. But isn't there another side to this? I've heard the argument, I think Jan LeCun mentioned it, that machines might actually be easier to debias than humans.
Yeah, that's an interesting and maybe optimistic take.
Yeah.
LeCun's point is that human biases are deep-seated, often unconscious, tangled up with emotion, really hard to fix. Machine bias, on the other hand, is ultimately rooted in data and math. So in theory, if you can identify the biased data or the problematic weights in the model, you could potentially correct them programmatically.
Okay, so it's more like debugging code, potentially.
Sort of,
Yep.
but it's much harder in practice than it sounds. First, getting perfectly clean representative data. That's incredibly difficult.
Right.
And even when you try to fix a model, say, by correcting the examples it got wrong, if you only focus on the mistakes, you might accidentally introduce new biases, affecting the things it was getting right before. It's a really delicate balancing act, a constant process. 3, the black box. Transparency and understanding AI's decisions.
Okay, so bias is one major hurdle for trust. Another huge one is this black box problem. We put data in, get an answer out, but often have no real idea how the AI reached that decision. Why is that so common, especially with powerful systems?
Yeah, this is a big one. Many of the most successful systems, especially in deep learning, are incredibly complex. Think millions, even billions of interconnected parameters. And understanding exactly how those connections lead to a specific output, it's often beyond our ability to easily trace or explain. Judea Pearl, he's quite critical of this. He calls them black boxes that just generates answers.
Just answers, no reasoning.
He sees it as a limitation, this focus purely on prediction without understanding the why. Getting these systems to work well often involves tuning lots of settings, hyperparameters, and making design choices that feel more like an art or even alchemy than a clear science.
Alchemy? That doesn't sound very reassuring.
Well, it highlights that we don't always have a neat step-by-step explanation for why a particular setup works best. And if you can't explain how a decision was made, especially a high-stakes one, well, how much can you truly trust it?
Exactly. Which brings us to something even more alarming, I think, these adversarial examples. What are they, and what do they tell us about how fragile AI perception can be?
Adversarial examples are deeply unsettling, and they really question the robustness of these systems. They're tiny changes made to input data changes, often completely imperceptible to a human that cause the AI to make a massive mistake.
Imperceptible changes, like what?
Okay, so researchers have designed special patterns on eyeglass frames, put them on, and a state-of-the-art facial recognition system suddenly thinks you're someone else entirely.
Wow, just from glasses.
Yeah. Or think about self-driving cars. People have shown that putting small, seemingly random stickers on a stop sign can make the car's vision system read it as, say, a speed limit sign.
That's terrifying.
It is. Even in medicine, slightly altering pixels in an X-ray image, in ways a radiologist wouldn't even notice, can flip an AI's diagnosis from 99% confident no cancer to 99% confident cancer.
Oh my God.
What this shows is that AI systems don't see or perceive the world like we do. They're keying in on statistical patterns, and those patterns can be manipulated in ways that exploit their non-human way of processing. They're powerful, yes, but potentially very brittle.
Brittle.
Yeah.
That vulnerability seems like a massive barrier to blind trust, if it can be fooled so easily by things we don't even see. 4, navigating the minefield. The risks of blindly trusting algorithms. Okay, so this brittleness, the bias, the lack of transparency, it all points towards wider societal risks, doesn't it? Beyond individual errors, what are the big picture implications if we rely too heavily on these systems without fully understanding them?
There are definitely several major areas of concern. One that gets a lot of attention is autonomous weapons.
Lethal autonomous weapons, or LAWWs.
Right. Stuart Russell makes a powerful argument here. He says their scalability, the fact that maybe just a few people could deploy millions of them simultaneously, makes them potentially comparable to weapons of mass destruction. It raises profound ethical questions about delegating life and death decisions to algorithms. Can we ever trust a machine with that?
It's a heavy question. What do others think?
Well, Jan LeCun, while agreeing that AI can be used for weapons, pushes back a bit on the WMD label. But he strongly agrees on the need for international agreements and regulations, focusing on the applications of AI, especially military ones, rather than trying to regulate the research itself.
So controlling the use, not the science.
That seems to be the consensus direction. Then there's the whole economic impact, jobs.
Ah, yes, the robots are taking our jobs. Fear. How real is that threat, according to the experts?
It's complex. with different views. People like Martin Ford and James Manica see the potential for really significant disruption. AI isn't just automating manual labor anymore, it's tackling cognitive tasks, intellectual work.
Things we thought were uniquely human.
Exactly. Ford is perhaps more pessimistic about job losses. Manica is a bit more optimistic, suggesting that while some jobs disappear, new ones will be created, potentially more than are lost, though. That depends on certain assumptions.
By previous technological shifts.
Ray Kurzweil draws that parallel to the Industrial Revolution. Specific skills became obsolete, yes, but overall employment and living standards went up eventually. He sees AI leading to new kinds of human work.
But that transition could be rough for a lot of people.
Absolutely.
Yeah.
And that's where people like Daniela Rus emphasize the crucial need for massive retraining efforts, for adopting a lifelong learning mindset. We'll all need to keep adapting.
And who pays for that? Who manages it?
Good question. Jan LeCun points out the concentration of AI power in a few big tech companies. He argues governments must step up, invest heavily in education and support systems to prevent the gap between those with AI skills and those without from becoming a chasm. It's about ensuring a just transition, really, building trust in the societal outcome.
Okay, so economic disruption is a real near-term concern. What about the more sci-fi scenarios, superintelligence, killer robots taking over? Should we be worried about that now?
This is where you see a real split among AI thinkers. Nick Bostrom, for instance, talks about the control problem. The risk that a future superintelligence might pursue goals that aren't aligned with human values, potentially with catastrophic results.
The paperclip maximizer idea, kind of?
Something like that, yeah. An AI told to make paperclips ends up turning the whole universe into paperclips because it wasn't given the right constraints. But many other leading researchers think this is looking way too far ahead.
Like who?
Andrew Neg famously compared worrying about evil AI today to worrying about overpopulation on Mars.
Huh. Okay, so not an immediate problem in his view.
Right. He and others like Josh Tenenbaum argue that current AI, even the most advanced, lacks any real self-awareness, consciousness, or genuine goals of its own beyond what we program into it. There's no desire to take over.
So the existential risk is maybe overblown for now?
That's their perspective. They argue focusing on these distant threats distracts from the very real present-day ethical challenges we've been discussing: bias, fairness, transparency, economic impact.
It sounds like the biggest immediate danger isn't necessarily AI becoming too smart or malicious, but rather us over-trusting systems that are powerful but still fundamentally limited, still lacking common sense.
I think that's a perfect summary. That's the crucial insight from experts across the board. Gary Marcus, Judea Pearl, David Ferrucci, Barbara Gross, Oren Etzioni, Josh Tenenbaum, they all point this out.
What's missing?
Deep learning is amazing at pattern recognition in specific areas, but it lacks genuine common sense, causal reasoning, understanding cause and effect abstraction, the ability to generalize knowledge flexibly to new situations like humans do.
Can you give an example of that limitation?
Sure, there are these things called Bongard problems. They're visual puzzles requiring you to spot an abstract rule distinguishing two sets of simple drawings. Humans usually get them pretty easily.
Okay.
Even the best AI systems struggle massively, even with thousands of examples. They just don't grasp the underlying abstract concept. They're brittle. They fail unexpectedly when faced with something truly novel, something outside their specific training data.
The long tail situation.
Exactly. And that brittleness, that lack of deep understanding, makes blindly trusting them incredibly risky. We're trusting sophisticated pattern matching, not genuine intelligence or understanding in the human sense. Outro.
So where does this leave us on trusting the machines? It seems pretty clear from our dive today that AI has incredible potential, but trust, well, it isn't automatic. It's not guaranteed.
Not at all. It's something that has to be earned continuously by the systems themselves, and maybe more importantly, by the people and organizations building and deploying them.
Yeah. And the focus maybe shouldn't just be on what cool things we can build.
Exactly. As Barbara Gross argues, we need to think about what systems we should build. Getting bogged down in, dramatic, far future scenarios can make us ignore the real ethical challenges we face right now. Bias, transparency, responsible use.
And that's where you, listening, come in. Understanding these complexities, how AI learns, where bias creeps in, why it can be a black box, its limits and common sense. It's all crucial for navigating the world we live in now.
Yeah, it really prompts a question for you to think about. Where do you draw the line? How do you balance the convenience AI offers with the need for critical thinking?
How much transparency do you need? How much explainability from the algorithms shaping your news feed, your loan applications, maybe even your medical diagnoses?
And what role should ethics play? Not just as an afterthought, but baked into the design from the start. Consider how you, just by being informed and asking questions, can help push for a future where AI truly serves human interests and earns our trust.